Thank you, Alvaro. Good evening, everybody. My name is Edwin Garcia. Actually, I'm trainer professor at the University of Antioquia, Colombia. My research interest is related with landslides, especially physical modeling, couple modeling on saturated soils. And it's a pleasure for me today to present one of our research entitled Implementation of the TRIGRS model with reliability analysis for hazard assessment of shallow rainfall trigger landslides. This work was developed together with García-Aristizábal, Roberto Marín, and Juan Carlos Guzmán Martinez. As an outline of my presentation, firstly, I am going to introduce the topic of shallow landslides. After that, I will show some components of the TRIGRS model, the methodology we use, coupling triggers with probabilistic analysis. And after that, I will present the deterministic results and the probabilistic results. Finally, I will conclude with some comments about the research. To begin, it is important to mention some mechanics and definition of the topics we are going to deal with in this presentation. Rain-triggered landslides, also called soil slips or shallow landslides, are mass movements with the plane of failure parallel to the slope, small thickness, we consider around 0.32 meters, no more than that. And also they have small scars. They are usually generated after intense or continuous rainfall events, but rapid increase in pore pressure or loss of apparent cohesion. It means reduction of suction or increase of the negative water pressure. Subsequently, the displacement mass by liquefaction or rapid reduction of the strength as under rain condition becomes a flow that propagates down a slope. Here we can see a picture that shows a little what is the behavior after infiltration of the soil, and we can see after saturation of the material, we can have a very parallel plane failure after infiltration process. This infiltration of trigger and landslides is very complex, and they have a lot of variables to be included. One of the main is the rainfall, the intensity and the duration, but also how the soil is capable to receive the water is very important. If the soil can receive the water, there is some reduction of the strength of the surface, and even the water can come into the soil and accumulate in the saturated soil. So we have an increase in the pore water pressure and a reduction of suction on the surface. So that's why it's necessary to implement a model that considers the infiltration process in the stability analysis. Here we have a picture, some pictures of some events related with shallow landslides. As you can see, these events are from small thickness, and they have very small scarp area. Actually, the mass accumulation is due to the big number of landslides that we have, as we can see in the right picture. We can see many landslides, and after that we have a debris flow that can generate another problem or geological hazard. What is the idea of this research, or the main objective? We were thinking about susceptibility maps, which allow the identification of areas that are susceptible to landslides. So we can here see a picture of one municipality in which we employ the methodology, and we can see how we proceed in this study and how we can get the results. When we have susceptibility maps, we can take relevant measures to ensure disaster reduction. Also, we can offer safety to local residents, and with this, we can contribute to the formulation of territorial management plans in order to define some places for occupation. Let's go now to the TRIGRS model. TRIGRS model is defined as the transient rainfall infiltration and grid-based regional slope stability analysis. We are going to see next some components of the model that we understand it could be very interesting to analyze problems related with rainfall-triggered landslides. The program was developed by Baum et al., and it includes some information related with rainfall data, soil properties, topographical properties, and with one infiltration model, the program calculates the pore water pressure that can be positive or negative in order to introduce this information in a slope stability model to calculate a safety factor. Then TRIGRS can develop a spatial and temporal distribution on rainfall-induced shallow landslides. This model has a hydrological component which is in charge to calculate the transient pore pressure changes due to the rainfall infiltration. This is very important. It means that I can calculate how is the volumetric water content within the soil during different steps or different times according to the rainfall is applied to the soil. This calculation can be made under partially saturated condition or partially or totally saturated condition. This is one of the advantages of the model. In this process, because the model is transient, and by using a simplified analytical solution of the Richard equations proposed by Srivastava, it is possible to calculate with the time of the rainfall how is changing the volumetric water content on the surface and how the water is accumulated in the saturated zone. So the program can calculate them positive and negative water pressures according to the distance I need from the surface. Also, from an initial pore water pressure with a rainfall and a functional rainfall, I can determine in the program what is the variation of the pore water pressure according to the advance in time and the advance in the infiltration process due to the rainfall infiltration. Finally, to describe the exponential, the unsaturated between the negative water pressure and the volumetric water content, the program used a exponential hydraulic parametric model proposed by Gardner. It's a very simple model. It is made to make a linearization of the Richards equation. So it's possible to have some exponential function of the hydraulic conductivity and the volumetric water content to be implemented in the infiltration model. After this, finally, the program calculates how is the variation in the time of the safety factor, including positive or negative pore water pressure. This is one of the advantages, is a model that can include both cases, in the case of saturation and the case of unsaturated soil, so the information can be calculated. Methodology. In our case, we use for one region in Colombia, in the Aburrá Valley, not exactly in Medellin city. We use some information in order to make some susceptibility maps. Then we employ rainfall data. We use intensity, duration, and return period. We collect some geotechnical parameters, cohesion, friction, angle, and unit weight, hydraulic parameters, diffusivity, hydraulic conductivity, antecedent rainfall infiltration, and some geomorphological parameters as the dam, the flow direction, the slopes, and the soil depth. With this information, geotechnical parameters and hydraulic parameters, we generate some homogeneous geotechnical zones that I'm going to show later. The infiltration model is run, and after that, the stability model is applied in order to get a safety factor. However, as we get a lot of zones in geotechnical zoning, and this is a very huge area to be modeled, the parameters have some variation and uncertainty that is going to be considered in the analysis. Then, with some information that we collect from the government agencies, from the geotechnical studies on the area and technical literature, we prepared some groups of parameters for the geotechnical zones and made a probabilistic analysis. This probabilistic analysis was run through the FOMS method. The FOMS method is first order second moment. And in this method, it is important to know that we can calculate a reliability index. In this reliability index is an idea, or it has a relation with the probability of failure of the mass I am analyzing. Based on this, we can see that if we have a group of parameters, we consider for the methodology that the distribution of the parameters is normal. In that sense, I have here a deviation standard. If the deviation standard is larger, it means that the reliability index is lower. Then we hope that a higher reliability index values result in lower failure probabilities. Then this is a way to account when uncertainty in the parameters, and the results, as you are going to see later, are much better to obtain susceptibility maps. The results. This is the results of the municipality of Envigado. We calculate using the TRIGRS model deterministic safety factors for a return period of 10 years, intensity and duration obtained from the intensity duration course from rain gauge located close to the area. And we get some parameters, some safety factors less than 1 and very close to 1 in some areas that are related with larger slopes. Also, we run the program for 100 years with a larger intensity. What we found here is that these zones with low safety factor are associated with steep slopes. There is no big difference between the results of the two return periods. When we compare 10 and 100, there is no big difference, and this is due because the soils we are analyzing are soils with a low hydraulic conductivity. Then the water cannot infiltrate too much into the soil, so we don't have a large variation when we compare the results. On the other hand, we use the model and we apply the probabilistic analysis, introducing some variation in the cohesion, in the depth, and also in the friction angle. And with the same rainfall and same duration, we obtain the reliability indexes. As we can see here, we have another different result because we are taking the information, we are analyzing the information about hazard of the landslide, and we are seeing that the susceptibility map is showing a larger area because are including in the analysis some variation in the parameters. When we compare 10 to 100 years, there are no much difference, but the results from using the FONS method show a more critical behavior in terms of stability than the results given by the safety factor. Obviously, because we are using some variation in the parameters. To conclude, I would like to mention the following. This methodology allows for a better representation of the process of rainwater infiltration into the soil. And it includes combined process of stationary and transient infiltration, especially the transient infiltration when we have large period of rainfall are very useful to analyze the topic of a landslide triggered by rainfall. And they are coupled an infinitive slope analysis that considers the effect of the loss of strength due to the infiltration process. This loss of strength in the program is also very interesting because it's not only undersaturated but under unsaturated conditions also. TRIGRS is a deterministic methodology. It is not a program prepared for doing probabilistic analysis but if you accompany this analysis by probabilistic analysis as FONS, it's allowed to complement the results and to obtain critical failure areas depending on the triggering scenarios. However, it should be noted that FONS method tend to be conservative model by assuming the behavior of the random variables and the safety factor using a normal distribution. This is a very simple model, so it is not possible to have different probability functions of the parameters we are using. Rain-triggered and shallow landslide susceptibility analysis are decisive in defining land use in mountainous regions. This is especially in Colombia. We are working now very hard in defining the land use in many cities, so this is a very good tool to solve the problem. They can make a significant contribution to the land use planning. The models presented can be used as a landslide prediction tool as a part of early warning system. Some of the authors also are doing some exercises in applying these methodologies to early warning system. A limiting factor in the execution of this model is the lack of local study with the field data. We have large area of analysis, so we need a lot of parameters, but most of the time we don't have much information, or we have budget to do the field exploration. Then we need to get some parameters and to introduce the uncertainty of these parameters in the model. The models can be applied to other watershed as long as the thorough work is carried out through field campaigns for the acquisition of the soil parameter required by the program. Other type of analysis that can be carried out with this methodology are those involving assuming rainfall scenarios that induce mass models. This program can be useful to study how is going to be the problem of landslide associated with climate change. We have a large duration of the rainfall and large intensities, and how is this working and resulting in landslides over the time. This is my presentation. Thank you very much for your attention. This is my contact email. If you have any question or you have to give me any comment later, it was a pleasure to answer you. Thank you very much.